Hi, nice to meet you. My name is Jaewon Min from UIUC. I'm going to talk about Richardson's rule of key polynomials, also known as Thematic character of type A, usually denoted by kappa alpha, or using George notation is B alpha. Okay. Once again, let me start with sure polynomial with partition mu as mu x. Let me multiply it with another sure polynomial partition mu and expand it. So I need a coefficient here, which is Richardson coefficient. On the other hand, I can start with S lambda, but with two set of variables x and y, and try to separate the variables S mu x and S mu y. And again, I need a coefficient here, and once again, we have Richardson coefficient. Okay, so they are the same. So in this talk, I want to generalize it into key polynomials. So George defined a key polynomial, but let me recall some facts. So fact number one is whenever composition is weakly decreasing, the key polynomial is the single monomial. On the other hand, if composition is weakly increasing, the opposite case, then key polynomial is the same as sure polynomial, where I take my partition by reversing the order of composition. Okay. So let me try to multiply two key polynomials together. So let's start with key polynomial beta, multiply with key polynomial gamma. And key polynomial is the linear basis of polynomial ring. So I can expand it into a key polynomial. B. Sure. B. So let me denote the coefficient as B alpha beta gamma tilde. Unfortunately, this coefficient is not necessarily non-negative. This is not true. However, if I try to separate the variable, so I start with B alpha with two set of variables x and y, separate it. So B beta x times B gamma y. So I introduce another coefficient C alpha beta gamma tilde. This is in fact non-negative. So in this talk, I want to explain why this is true. Okay, so let me write down an example. So my running example is key polynomial 3, 1, 2, 0. So and I want to separate x1, x2, and y1, y2. Okay, so if I compute this rigorously, it should be key polynomial 3, 1, x1, x2 times key polynomial 2. Yeah. 2, 0, y1, y2 plus key polynomial 3, 2, x1, x2. Key polynomial 1, 0, y1, y2. So you can see that it is positively expanded. So in this picture, if I introduce another weakly increasing composition beta and another weakly increasing composition gamma, and I define mu partition, and I define mu partition, and in this picture, this C lambda mu nu, the usual Richardson coefficient, should be the same as this coefficient that I define. In this sense, this is indeed a generalization. So why this is non-negative? So this is not my theorem. This is sort of a folklore. So let me use two theorems to explain why that is true. So theorem number one is by Anthony Joseph, 1985. So in this framework, let's think about a ring R, which is not necessarily commutative. Let's think about a module, R module M. So M, the module M is cyclic, which means that there is one generator. This condition, cyclic module, is equivalent to the condition that there exists an ideal I, such that M is isomorphic to the quotient. So Anthony Joseph think about the module, and he think about the ring as the universal enveloping algebra, and it has one generator, which is Rho's great factor. And then in this framework, you can think about what is the generator of this ideal I. And Anthony Joseph answered that question. That is theorem number 1. So theorem number 2 is, let's think about B alpha beta gamma that I defined earlier. This is not necessarily non-negative, but it is non-negative. If I assume that D beta or D gamma, the key polynomial, one of them is a monomial. This is proved by several people, but I'm gonna refer to Oliver Matthew, 1989. Sure. So let me combine these two theorems to explain why this is positively expanded. So first of all, I'm gonna pick large enough number n. In this running example, let me try 10. Okay. So I'm gonna multiply key polynomial 3120 with key polynomial 10, 10, 0, 0, which is a monomial. And by the theorem of Oliver Matthew, it should be positively extended. 1, 3, 13, 11, 2, 0 plus 13, 12, 1, 0. And using the theorem of Anthony Joseph, you can find the bijection between these two terms, here to here, which prove that it should be positively expanded, which prove that this is non-negative. For the remaining time, let me add one more sentence about my own research. So my research is about multiplicity freeness of this U constant, how to classify it, and what is the geometrical meaning of this. Thank you for listening.
Do we have a question for Jaewon?
Can you give a 1 or 2 sentence, a little more about your research?
Yes. So key polynomial is actually the character of the global section of line bundle over Schubert variety. So key polynomial has a connection to Schubert variety. So this has a connection to Schubert variety being spherical. Which means that there should be a dense B orbit in XW.
Okay, thanks Jaewon again.